This is the next in a series of examples of how to do stoichiometry problems. We are now looking at a limiting reagent problem. So these typically come with a series of sequential questions, starting with what is the limiting reagent, and then how many grams of one of the products can we produce, and finally, how many grams of the excess reagent do we have left over. So we're going to consider this reaction, gold sulfide plus 3 hydrogens gives us 3 hydrogen sulfides and 2 gold atoms. We're going to start with 3.894 grams of gold sulfide and 1.865 grams of hydrogen. My recommendation on the way to do this is just do 2 complete stoichiometry problems, and it's very easy to answer the first 2 questions. So, we're starting with a certain number of grams of gold sulfide and a certain number of grams of hydrogen, and we want to know how many grams of gold do we produce. So we have one ending point, which we're going to get to, starting from either gold sulfide or hydrogen gas. So we'll do this just like a regular stoichiometry problem, just in 2 steps. So I'm going to start with the gold sulfide. I have 3.894 grams of gold sulfide, which I do my grams to moles to moles to grams roadmap. So grams of gold sulfide to moles of gold sulfide, moles of gold sulfide to moles of gold to grams of gold. I do exactly the same thing for hydrogen. I have 1.865 grams of hydrogen to start with. I convert it to moles of hydrogen. I convert moles of hydrogen to moles of gold, and then moles of gold to grams of gold. So I'm going to need the molar mass of gold sulfide. I'll need the stoichiometric conversion from gold sulfide to gold. So the reaction says 1 gold sulfide gives me 2 gold. And then I'll need the molar mass of gold. And then I also need the molar mass of hydrogen. The stoichiometric conversion from moles of hydrogen to moles of gold. So 3 moles of gold gives me 2 moles of gold, 3 moles of hydrogen gives me 2 moles of gold, and then moles of gold to grams of gold again is the molar mass. So now I'm ready to whip out my periodic table and my calculator, and so gold sulfide, the molar mass is 2 times the molar mass of gold, which is 196.97, plus 3 times the molar mass of sulfur, 32.06. And so the molar mass of gold sulfide is 490.12 grams per mole. The molar mass of gold then is just 196.97 grams per mole. And the only other thing then I need is the molar mass of hydrogen. So 2 times the molar mass of hydrogen, and I get that. And now I'm going to do my conversions, starting from my starts and ending at my ends, doing it for each one separately. So let's start with 3.894 grams of gold sulfide. Converting grams of gold sulfide to moles of gold sulfide using the molar mass. So I want grams of gold sulfide to cancel. So I put the molar mass on the bottom per 1 mole of gold sulfide on the top. Moles to moles, it says 1 mole of gold sulfide, which I want to cancel. And turn it into the 2 moles of gold. And then convert moles of gold to grams of gold. So 1 mole of gold goes to 196.97 grams of gold. And so now my units should cancel grams of gold sulfide with grams of gold sulfide, moles of gold sulfide with moles of gold sulfide, moles of gold with moles of gold. All I have left is grams of gold. I set up exactly the same conversion for hydrogen to gold. So I start with my 1.865 grams of hydrogen. I have 1 mole of hydrogen over the 2.016 grams of hydrogen. I have 3 moles of hydrogen to 2 moles of gold. And then I have the same conversion from moles of gold to grams of gold. And again, grams of hydrogen cancels with grams of hydrogen, moles of hydrogen cancels with moles of hydrogen, moles of gold cancel with moles of gold. I get grams of gold. So now I'm ready to do my math. So 1.865 times 1 divided by 2.016 times 2 divided by 3 times 196.97 divided by 1. I can get 121.5 grams of gold from my 1.865 grams of hydrogen. And 3.894 grams of gold sulfide divided by 490.12 times 1 times 2 divided by 1 times 196.97 divided by 1. And I can get 3.0130 grams of gold from my 3.894 grams of gold sulfide. So now we're ready to answer the first 2 questions. This is the hard part. Look at the 2 numbers. Which one is smaller? Because that's all we can get. So this is the grams of gold we can produce. And I just track back to the beginning of that, and that compound is my limiting reagent. So I can say my limiting reagent is the gold sulfide, and the grams of gold I can produce is 3.130. So then we have the last part of the question was how much of the hydrogen is then left over. So we can figure that out. We started with 1.865 grams of hydrogen. How many grams of hydrogen did it take to produce the 3.130 grams of gold? So we're just going to do this reaction over here backwards. We're going to start with the amount of gold we produced from the gold sulfide, and we're going to calculate how many grams of hydrogen it takes to produce that many grams. So we're going to start with this many grams of gold, and we want to know how many grams of hydrogen does it take to produce that many grams of gold. So we do our usual grams to moles, moles to moles, moles to grams. Now I don't have to look anything up in this case because I've already calculated all these conversion factors. The molar mass for gold is right here. The mole to mole conversion is in the reaction, or right here. And the molar mass of hydrogen we calculated earlier. So we do exactly the same kind of problem. We start with the grams of what we know, and we end with the grams of what we want. So we know we're starting with the 3.130 grams of gold. Convert grams of gold to moles of gold using the molar mass. Convert moles of gold to moles of hydrogen. Using the stoichiometric conversion, and then convert moles of hydrogen to grams of hydrogen using the molar mass. Do my check again. Grams of gold cancels, moles of gold cancels, moles of hydrogen cancels. I get my grams of hydrogen. So I can do my calculation. The 3.130 times 1 divided by 197.97, 196.97, times 3 divided by 2 times 2.016 divided by 1, and I get 0.04805 grams of hydrogen is how much I need. And so the grams of excess reagent is how many grams we start with minus the grams that we need to use, and that will be our grams left over. So we started with the 1.865 grams of hydrogen. We just calculated that we needed 0.04085 subtract the 2. And I have the grams of hydrogen left over. So that's the last part of this question up here. And so that's all 3 parts of doing a limiting reagent problem. Quite often you just get the first 2 parts, but you may also be asked the 3rd part, so I've shown you how to do all 3 parts. Thank you.